So the next topic in first order differential equations is going to be the exact equations. So you might have encountered certain types of equations which might not be solvable through the separation of variables or the linear integrating factor method. In that case, we might try if it's going to be an exact equation or not, and if it is, then how do we solve it? That's what we're going to look at this video. Usually we define the general form of an equation to check if it's going to be exact is m of xy plus n of xy times y prime is equal to 0. So usually if we think that the given differential equation can be written in this form, if it is in this general form, then we would check if the equation is going to be exact or non-exact. So how do you check if it's exact? And before that, we need to know what m and n are. So we define a common function psi, which is also a function of x and y. And when we partially differentiate psi with respect to x, we define that function as m, which is a function of x and y. Similarly, if we partially differentiate psi with respect to y, we say that function is going to be n, which is also a function of x and y. So you might have noticed that since psi is the same term and we are differentiating with respect to x and y, so if you're going to differentiate it again, you're going to partially differentiate m with respect to y now and partially differentiate n with respect to x, right? So we would get psi differentiating with respect to x and y would be m of y, right? So that means I'm partially differentiating m with y. And if I'm doing psi with y and then x, that's just partially differentiating n with x. As you can see, psi xy and psi yx has to be the same, right? So, but there are still cases when it might not be the same. So we're going to check if psi xy is equal to psi yx, or in other words, my is equal to nx. So if this condition is satisfied, then we say that the equation which we have is an exact equation. Okay? So after we check if the function is exact or not, we proceed towards solving it. So before going there, I'll be doing an example of an exact equation in my next two videos. But I want you to understand if this part is clear, because the common mistake that people might make is going back to y as a solution. But over here, we are defining psi as a solution to this equation. Psi is a function of x and y again. So how our solution would look like, if you think about it, we'll be having my and nx, right? And if they are both equal, we say that it is an exact equation. So we're going to start from one step above this so that we can integrate just once and we'll be done. So I'm going to take m of xy and integrate it with respect to x. So then I would get psi over there. And similarly, if I do that, I would also get a psi. So the common terms in both the equations plus a constant would have to end up with the function psi, which should also solve this equation for us. So this is going to be the general way of solving it, and I'll cover the examples in the next video.